on to question 6 of paper 2, and the first part, which is part A. The question says, the probability that the 8 o'clock train will be delayed on a workday is 1/10, and assuming that delays occur independently, we have to find the probability that the 8 o'clock train is delayed exactly twice during any period of 5 workdays. We first have to find out what distribution this is, because we know that the probability of success, which is the probability that the train will be delayed on a workday, is 1/10, which is 0.1. And we also know that the number of trials is 5, so we can see that we have to use binomial distribution for this particular question. So binomial distribution is this. So we have to find the n and the p, which is n, which is the number of trials, and p is the probability of success, which we have already found out from here. So if we use that, then we can get the probability that the train is delayed exactly twice, where x is 2, exactly twice, is equal to statistics, distributions, binomial PDF. N we know is 5, probability of success we know is 0.1. How do we do this? So we can see that the answer is 0.0729. Moving on to the second part of the question, which asks us to find the minimum number of workdays for which the probability of the 8 o'clock train being delayed at least once exceeds 90%. So we know that we have to find the n in this case, because the probability of success is still the same, but we need to find the n. Probability of success is still 0.1, and the number of trials, we have to find the number of trials. So if we do the binomial, which is n0, 1/10 to the 0, 9/10 to the n, has to exceed the probability of 90%, so has to be within 0.1, which is 10%. This becomes 1, and this becomes 1, so we can see that 9/10 to the power of n has to be smaller than 0.1, which is 10%. If we to do this, we have to find we can manipulate it, so we find the log. So we can do a log of 0.9, log to the base of 0.9, 0.1 is smaller than n. Therefore, if we do the calculation, we get that n has to be greater than 21.8543. So we know that the smallest n value is 22. Now if we put that back into the initial equation, we know that x is now, n is now 22. And so we have to find the probability of p exceeding at least once exceeding 19%, which is 0.9. If we do that on the calculator, we get the value p is 0.902 using binomial CDF, which is this. So the final answer is 0.902.